Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and in this video, we're going to take a look at the standard addition algorithm here in the US. Now, notice that the first word is understanding, and there's a little bit more to it than how we might have learned it as young children. I remember learning the addition algorithm, how to add two-digit, three-digit numbers, multi-digit numbers, using words like carry and borrow for subtraction. Now you might have your child hearing words like regrouping, thinking of equivalent ways to make the numbers. And that's where we're going to start in building understanding. See, that understanding approach is really important because it will help your child not only learn how to add those regrouping type problems, but will also help them add not just whole numbers, but mixed numbers, what they'll need to understand for fractions and decimals. So it will carry over for them. So I hope you'll stay with me. I hope you'll see that connection as we go through, and then we'll also look at some language to use to help your child with that standard algorithm. Some children just have a hard time remembering all the steps and procedure. And we find that using some of this language and this understanding help those children who sometimes struggle with this. As I said, if your child gets those algorithms and procedures quickly, it's still an important understanding because it will help them when they get to fractions and decimals. Now you'll notice I have some place values blocks here, base 10 blocks. And you may see that some of your children are using these base 10 materials in their classes. We have the hundreds, the tens, the ones. And I have more of a 3D version, the commercial version. And you can see I have a paper version too. And this helps your child understand the relationships of hundreds, tens, and ones. My paper version is made from centimeter grid paper. You could easily make it yourself to use with your children at home. Now, the reason for this, and we'll look at a couple of problems just to get us started. Think about a number like, remove this page here. If you think of a number like 35, see, a lot of times when we think of this number, we think of its place value, 3 in the tens place, so we need 3 tens, and 5 in the ones place, we need 5 ones. But that's not the only way we can make the quantity 35 using tens and ones, right? You could make it with 2 tens and 15 ones. Think about money and coins. I could make 35 cents with 3 dimes and 5 pennies, but I could also make it with 2 dimes and 15 pennies. I could make it with 1 dime, 25 pennies, 1 dime and a quarter. See, there are equivalent ways to make this. So you may find that your child is asked to think of equivalent ways to make a quantity using tens and ones. And I'm going to start with a number like 62. See, this comfort, I could have used 35 too, but 62, see, I could make it with 6 tens and 2 ones. I could make it with 62 ones. As we said, 5 tens and 12 ones. I could make it with 3 tens and 32 ones. I could make it with 4 tens and 22 ones. I could make it with 1 10 and 52 ones. You get the idea. Now, when I do this with your children, when I do this with children, I'll have them talk about and notice all the ways, see if they have them all. Now, notice I haven't introduced this using a pattern because that creates problem solving for your child, and we want them to reason through a lot, build that reasoning capability. But I ask them which way use the fewest number of pieces. So if you notice this way, would use the fewest. It's actually using 8 of my base 10 pieces, 6 of the tens rods, 6 of these, and 2 of the ones. Okay, and then which one uses the most? And those are important things to notice. Now, the reason this is important, and let me just show you with a problem like this. I'm going to use a subtraction problem to show. See, 62 minus 29, I need more ones. What's an equivalent way that I could make 62 that would give me more ones? Notice I'm not borrowing. I'm thinking of it as equivalency. I could make it with 5 tens and 12 ones. Okay, that equivalent way to make a quantity using tens and ones is going to be important, and understanding fewest pieces and most pieces will be important to build the understanding of that traditional algorithm. Now, I could do this for hundreds, tens, and ones. What if I had the number 237? Right? I could make it with 2 hundreds, 3 tens, 7 ones, 23 tens, 7 ones, 237 ones. You get the idea that that comfort, that fluency is important. And when I get here, the equivalency, see, I could also do it with decimal numbers. I could use this with fractions, but my headings might be wholes, halves, thirds, fourths, sixths, eighths, right? Equivalent ways to make it. So again, I could do this with 2 ones, 3 tenths, and 4 hundredths. I could do it with 234 hundredths, right? I could do it with 2 ones and think of this as 34 hundredths, which is the way we talk about it. Okay, so equivalency, again, important idea. Now let's look at that traditional algorithm. This time, let's add 62 and 29. Now, traditionally, in the algorithm, you start with the ones and you work your way to higher place value, okay? But I'd like you to listen very carefully at my language. If I have 2 ones and 9 ones, how many ones do I have? I have 11 ones. What's an equivalent way I could make 11 ones with the fewest number of pieces? Well, I could make it with a 1 and with a 10. Now, I've got 1 10, 6 tens is 7 tens, and 2 tens is going to be the 9 tens. Do you notice how by using this language, I'm essentially doing that traditional algorithm, but I'm also talking in terms of place value. The way I learned the traditional algorithm, every place was the ones place. You ignored place value when you did it, and you just added ones. With that language I'm using, I'm actually using it in a way that preserves place value and lets them do it in a very efficient way, find the total. Okay, if we looked at, let's do another one, 378 plus, see, we traditionally start on the right, 8 ones and 6 ones. That's the key, preserve place value. 8 ones and 6 ones, 14 ones. How can I make it using the fewest number of pieces? Well, I can make it with a 10 and 4 ones. Now, one thing we want your child also noticing is being playful with numbers, knowing that with addition, I don't always have to go straight down the column. See, I notice immediately the 1 and the 9 gives me a 10, so that's an easy way to make 17. I could have, of course, said 1 and 7 is 8 and 9 is 17, but I've got 1 10 and 9 tens is 10 tens, and 7 more tens is 17 tens. What's a way I could make it using the fewest number of pieces? Well, I could make it with 100, 100, and 7 tens. Now I've got 100 and 300s is 400s. 4 more gives me 800. Okay, so it's not about carrying as I was taught. It's about regrouping, rethinking of 17 or 18 14 ones or 17 tens as 107 tens. We're regrouping, we're rethinking of it in fewer pieces. Now, as I said, this is really important as we keep going. See, even thinking about, let's add 2 and 5, 6, 4 and 3, 6. Okay, we know we add wholes to wholes. The 2 and the 4, we know we're going to have 6, but this is the part, right? I have 5 1/6 pieces. I'm putting it together with 3 1/6 pieces, so that gives me 8 1/6 pieces. Okay, 8 6. What's a way I could make 8 that equivalent to 8 1/6 pieces using fewer pieces? Well, I could do it with a whole and 2 of the 1/6 pieces. Okay, so I've got that whole, 3, 7 wholes, and 2 1/6 pieces. Now, again, what's the equivalent way I could think of this using even fewer pieces? Well, 2 1/6 pieces will be the same as a 1/3 piece. That equivalency idea, we want your child to keep thinking of equivalency, because that's what's going to help us with addition, but even more importantly, with subtraction. If you found this video helpful, please give it a thumbs up. Consider subscribing. It's free right now, so subscribe, no cost to you. Click on that notifications bell, share with others who might find this helpful. Again, this language will help us not just get answers to those addition problems using that traditional algorithm, but it also will build understandings of place value, reinforce that, and build foundations needed when we get to mixed number addition. I appreciate you watching. I hope to see you in other videos. Thanks so much for watching.